Estes empis, res vano intensis, dres lies blue. I set the fire that once on fire. Let flames aspire over many to perish.
The fire has just been lit by Mr. Wolf, the president of the Archaeological Society, and we will wait a little bit till it gets going before performing the sacrifice.
Night bonfires to signify some incoherent, long-forgotten message. Obscure dawn rituals to gratify the ancient fertility of the sun. This is one idea of life in the Stone Age in Britain, a savage grandeur, profound mystery. But was it necessarily so? Up and down the country, in Scotland and England and Wales, there are hundreds of prehistoric sites drowning in mist and heather, as remote and incomprehensible as the men who put them there at vast expense of toil 4,000 years ago or more. Stones in circles. Stones standing in stiff-shouldered lines, marching nowhere, doing nothing. What were they for? Why should a simple, primitive people scratching a living from the land go to such trouble to build these seemingly pointless monuments in the middle of nowhere? Was it simply for ritual or for ceremonial? One man claims to have found in the stones a reality about our ancestors more fascinating than any fiction. For over 30 years, this man has devoted all his spare time to tracking down his prehistoric counterparts. He's 76 years old now. Alexander Thom, a Scot, one-time professor of engineering science at Oxford University. By studying hundreds of these half-forgotten sites, he's produced a theory that may force us to modify our preconceived ideas. To him, Stone Age people were not just simple primitives, but could be intelligent and sophisticated mathematicians and astronomers, for whom time was an exercise in science, using stones as calendars and clocks. Men who could measure and survey with the accuracy of a modern theodolite.
It's intensely interesting. I get a tremendous thrill when I come over the top of a hill and see a circle lying in amongst the heather, and I realise that he's anew, and maybe anything come out of it.
You assume now that there must be some reason, some scientific or mathematical reason for the stone being there, and therefore you are not content until you've cracked it.
Well, in some cases you can't get anything because there may only be one or two stones left, and the site's incomplete. In other cases, well, it took me 20 years to crack the most important of all. It was worth cracking.
Bin Daniel.
I think the first thing one must remember is that all professional archaeologists are beset by the lunatic fringe of archaeology. And the second thing to remember is that Professor Thom is not part of this.
At his home near Dunlop in Ayrshire, Thom buries himself every day in a converted henhouse to process the patient surveys that have set the world of conventional archaeology by the ears. Professor Stuart Piggott.
As archaeologists, we are sometimes accused, as other people are in specialized disciplines, of being a closed shop and preventing unorthodox and new ideas. I don't think this is the case at all. We are perfectly prepared to accept new ideas if they are examined and stated in the terms of archaeological evidence. In other words, you've got to be an archaeologist before you can start putting forward new ideas about archaeology.
Well, Professor Thom is not an archaeologist. He's an engineer. He's established to his own satisfaction that Stone Age man used a standard unit of length for all his work, a megalithic yard of 2.72 feet precisely that was consistent throughout Britain, implying an organized society with an agreed yardstick. His theories about megalithic geometry and astronomy have been described as putting a time bomb under archaeology. Take Avebury Ring, for instance. To him, not just a prehistoric temple, a stupendous exercise in Stone Age geometry made by mathematicians and astronomers. And this is the nub. For Thom has found dozens of alignments between individual stones and the setting and rising positions of the sun 4,000 years ago. He subjected all these observations to statistical analysis. On a chart, it emerges that these alignments fall into groups that correspond with remarkable accuracy to the major solar events of the year, winter and summer solstice, spring and autumn equinox, and so on, to form a Stone Age calendar of 16 months, and one that could be synchronized throughout Britain, perhaps by beacons of which May Day and midsummer bonfires are an ancient memory. It's heady stuff, suggesting a race of prehistoric Einsteins. But not all archaeologists are wholly convinced, to say the least. One of his chief critics is A.H.A. Hogg.
That I question how much of the prehistoric Einstein's calculations have been put in by Professor Thom inadvertently.
Ewan Mackay.
I think there is a very real danger that we may underestimate what our prehistoric ancestors were capable of, simply because we perhaps subconsciously tend to assume that the evidence we have is the only evidence.
So what Thom has done is he's emphasized by studying not only the grand monument like Stonehenge, but all the stone circles in the north of Britain. He's studied these things and made us appreciate again, all of us, that there was an accurate body of engineering and mathematical knowledge in times which are very long ago.
Jaquetta Hawkes.
But could simple herding societies, semi-nomadic even, really have this very elaborate mathematical systems and astronomical systems, nothing you see could be recorded or handed on?
But we know already they were accomplished engineers. Richard Atkinson is one of the few archaeologists with the knowledge to evaluate the mathematics of it.
I think that this has to be taken very seriously indeed. No one, I'm sure, is going to question the accuracy or comprehensiveness of the evidence which Professor Thom has put before us. Where people are going to have difficulties with the implications of the evidence. And if we accept the implications, admittedly we're accepting something which, to us as archaeologists, sounds pretty improbable. But I still think we've got to take it seriously, simply because if we reject it, we are, in fact, flying in the face of a great deal of evidence which cannot be explained away simply as a result of chance or accident.
Unruffled by controversy, Alexander Thom works on, getting closer and closer to the megalith builders he has come to respect and know so intimately that he calls them now the boys.
The problems they solved without pen and pencil and without logarithmic tables and so on were remarkable. I think they were, as far as brain power is concerned, they were my superior.
He has set himself an enormous task. For the megalithic culture is found all over Europe. His boys were astonishingly assiduous in their building and liked to do it in style. The scale is sometimes breathtaking. At Carnac in Brittany, the most spectacular megalithic site in Europe, thousands of massive stones stand there in great battalions, line upon line, striding across the countryside for miles on end. The standing stones have survived because of their sheer weight. So have many of their tombs, roofed with great slabs of stone, some now stripped of their covering of soil and exposed to the light, others in the form of covered passage graves. And in these passage graves we find their mysterious art carved in the massive stones. Carnac is not the only place where stone alignments have survived. There's the Avenue of Stones at Avebury, for instance, but on a much smaller scale. On Dartmoor you find similar lines of stones, but unlike the Carnac lines, they don't stride over the countryside. They trudge on aimlessly for miles. But they are recognizably part of the megalithic culture, for megalith is simply the Greek for big stone. But apart from these vestigial alignments, Britain, and particularly the west of Britain, is littered with circular structures, rings of stones that Alexander Thom has studied so minutely, many of them almost lost in the heather and in ruinous condition, but some of tremendous tremendous power and majesty, like the great monument of Avebury with its enormous ring of standing stones. A place of mystery and magic for thousands of summer visitors, rivaled only by the sheer grandeur of Britain's most celebrated prehistoric monument, Stonehenge itself. The ancient Greek historians may have known it as the great circular temple of Apollo they described in the islands of the Hyperboreans north of France. These Hyperboreans, they said, were skilled astronomers who visited the Greeks in turn, what's more, and taught philosophy to Pythagoras and his followers. And that's pretty astonishing, for according to Professor Thom, the megalith builders were using Pythagorean geometry to design their circles almost 2,000 years before Pythagoras was born. On a sandy shore in the west of Scotland, Alexander Thom treated me to a Hyperborean seminar, a prehistoric tutorial in engineering, demonstrating with pegs and knotted string how his Stone Age designers had used Pythagorean triangles, right-angled triangles whose three sides are all whole numbers, as a basis for their circular designs. For many of the stone rings are not true circles, but subtle variations of a circle. Any fool, it seems, can draw a circle with a stick and a piece of string, but that didn't satisfy these Stone Age Einsteins. At first glance, the rings of standing stones look like circles, but Thom's meticulous surveys have revealed that frequently they are not, like the ring at Penmyn Moor in North Wales. It's actually an ellipse, or oval, the easiest modified circle there is to draw, once you know how.
Or, as it's called mathematically, an ellipse. But you notice that it's drawing to two centres. Now this again gave them a certain choice in the size that they made this.
This choice was to enable them to make all the resulting measurements integral whole numbers, based on a Pythagorean triangle measured in that standard unit of length, the megalithic yard.
3, 4, 5.
The ring at Mynehirion, for instance, is an ellipse drawn from two centres with a long loop of rope, designed expressly to make the circumference an exact number of megalithic yards. There are 10 of them in Scotland, 3 in the West Country and 2 in Wales.
4, 3, 7. So I proceed to come from
the next way of modifying a circle was to stretch one end of it into an egg shape based again on the Pythagorean triangle, whose integral sides ensured that all your measurements stayed integral apart from the circumference, and you had to experiment for years to get that integral as well. And this seems to have been one of their chief intellectual preoccupations.
And I go ahead from here again, clearing the nail. And there's the egg completed.
The so-called Druid temple near Inverness is based on a classic Pythagorean triangle, its sides precisely 3, 4 and 5 megalithic yards. There are 6 of these egg-shaped rings in Scotland, and the timber ring at Woodhenge in Wiltshire is also an egg, not a circle.
Well, it has significance for geometry. They're storing away the fact that they know that that's a 3, 4, 5 triangle. But there's another point, and that is that the circles and the rings were all made so that the circumference was an integral number of units. And now, if you're using eggs, you have far greater freedom to adjust matters, because you, having put down your basic triangle, you can start off with any set of radii you like, provided they're based on the triangle. They'll all be, if one of them's integral, the other 2 will also be integral.
The cult of the whole number, or a dogged determination to impose their will on the obstinate stones. Sometimes, instead of making an egg shape, they clipped bits off the circle to flatten it. There are 20 of these in Scotland, 14 in England, like Castle Rig and Long Meg in the Lake District. Some compound rings were extraordinarily intricate, as if the designer had gone berserk. At Maltiuca in Wales, there's a 5-sided ring with a whole series of interlocking arcs and substructures. But if that's complex, what about Avebury, based on a massive Pythagorean triangle, the megalithic yard being used in units of 10, which seems to have some sort of mystical significance?
This is pure mathematics or pure geometry for its own sake, in fact.
Well, it might have been geometry for its own sake. I mean, these people were, well, they were researching into geometry. But all the time they were controlled by this convention that they had to have it whole numbers.
I suppose the definition of pure research is that it hasn't really any functional purpose. They didn't require to make their stone circles in this shape.
Well, that's true. They could just have drawn any old circle and said, there's a circle, boys. But they didn't. They wanted the thing to have perhaps this hidden significance. The man in the street, the ordinary man who helped them to set it out, wouldn't have any idea what was hidden in this thing. But the experts, the priests, or what you call them, they knew what was in it. This hidden information which was stored away in this construction.
Looking out towards the island of Jura, 19 miles off the west coast of Scotland, at a place called Ballachcroy, there are 3 stones standing close together on the hillside. From them, on a good day, you can see Ben Curra, one of the paps of Jura. It was here 30 years ago that Thom first realized that the stones could have been markers for making truly accurate observations of the summer solstice. The seminar turned to prehistoric astronomy.
Well, solstice was the midsummer day, and it was a calendar date, and he gave him a fixed point in his calendar.
But it wasn't all that important for farmers, for instance, to know when midsummer was. They would plant according to the seasons and harvest according to the seasons.
Well, but if the observers are going to predict some astronomical event such as an eclipse, it was necessary to have a calendar. You can't make predictions without a calendar.
Why should they want to predict eclipses?
Well, that I don't know, but it was obviously very important. You know the story of the 2 Chinese astronomers who had their head chopped off because they failed to predict an eclipse, so probably these chaps were just as anxious.
In 1970, the megalithic summer solstice no longer works here because of something that astronomers call the shift in the obliquity of the ecliptic. The Earth's axis is tilting, which means that the midsummer sun is setting a little further south each year. The difference can be calculated and allowed for, and Thom has worked out that in 1800 BC, an astronomer at the stone would have seen the setting sun just twinkling down the right-hand slope of Ben Curra and known the exact day of the summer solstice for his calendar.
But the point about this site is that it gives you a real accuracy, an accuracy of a minute of arc.
What's that?
A minute part of a degree, 60th part of a degree or better. You can get here. Such as quite impossible with, for instance, the Heelstone in Stonehenge.
Now, how did they operate this if it was a solar observatory? How did it work?
Well, as the solstice approached, the sun was coming up, getting a little further to the north every night as it set. Eventually, when it was near the solstice, it was very near the slope of Ben Curra, and the observer would have to move along here, notice right along the line of the stones, till he was perhaps somewhere out here. And he would move along here until he got the sun, the edge of the sun just twinkling down the slope of Ben Curra. And he would mark it. The next night he would find it to move along a little, get into the same position, he'd mark it again. By the time he got to the stones, he knew that the sun had reached its extreme position and it was the solstice.
Was this a case such as we had with geometry, that they simply wanted to know about calendars and astronomy as knowledge for its own sake? Or was it all put to some use?
Well, I think eclipse prediction was one of the things, but also there was the fact that just as today our astronomers like to produce a time and a calendar which is exact, a fraction of a second, if you like. These people were working to a fraction of a day. And they wanted to be accurate, just the same as our scientists today want to be accurate. They wouldn't have been scientists if they hadn't tried to be accurate.
Now, what is it that you do with your theodolite that Stone Age man was doing without his theodolite? What are you doing when you keek through it?
When I keek through the theodolite, I'm determining the exact azimuth of the exact bearing of the various points along the hilltop. I must get these exact to a minute part of a degree, so that I can do the calculations and say exactly what the declination was, and so I know that it was the edge of the sun that was coming down Ben Curra.
Well, let's have a look and see what happens when you keep through it. Now you stare through this. You take a bearing on the stone?
No, I don't touch the stone. I have previously from the sun determined the bearing of a reference point. by looking on the sun and using my watch. So I know the exact bearing of some reference point. So I get onto the reference point like this, set it on exactly, and now this is now set. Clamp up this, I can turn on to Bencora. I can do as many points along the slope of Bencora as I like, one after the other.
So this is how you can tell precisely how the sun was setting in, what, 1800 BC?
Exactly. I can only use a theodolite because I can't look at it in 1800 BC. They could, but I can't. I mean, the present position today would be way up there somewhere because of the change in the obliquity of the ecliptic. The sun is not coming so far up in the summer or so far south in the winter.
The maps of Jura could apparently be used as an astronomical foresight to observe the winter solstice as well, from a place on the mainland called Kintraw, 30 miles away. The site here consists of a standing stone, a large ruined cairn, a deep gully, and on the far side of the gully, 20 feet further up, a large boulder on a ledge like a platform. No one had paid it any heed until Tom went clambering up that tricky slope in search of a prehistoric observation platform.
Because I couldn't see how these boys had got the position without getting up. And obviously, if you go over there, you can get up as high as you like. And I thought, well, the obvious thing is to go over there and see if you can get a good view. Took the theodolite over there, and then I found myself on the platform.
This ledge was now being excavated by a team from the Hunterian Museum in Glasgow, led by Ewan Mackay, to see if there was any evidence that it had once been man-made.
Hello. Been here a week.
Had these Stone Age astronomer priests deliberately constructed this platform to help them in their astronomical observations on a December day some 4,000 years ago?
Professor, which is the platform itself, Ed?
Well, we're on it now. Where
This
I
whole
thought.
area here?
Yes, because you see, there's the wooded top which hides the paps when you're down at a lower level, but they come in just over the trees there when you're in the neighborhood of this stone. And that was how I spotted this bit that you can actually dodge back and forward on to get yourself into alignment.
Come and show me what a Stone Age man would have been doing if you were standing on this platform.
Well, this I reckon is where he actually made his first observations of the winter solstitial sun setting in the paps of Jura behind Benchanty. Now from here, the sun goes into the notch, goes in behind Benchanty, and then appears momentarily in the notch.
This notch where the knoll is there?
The notch is just over the knoll, just above where the standing stone appears from here. Now, the sun at the winter solstice setting went behind Benchanty completely, out of sight. And then it reappeared momentarily in the gap. Now, the problem for the megalithic observer here was to get himself into such a position that it just twinkled in the gap, in the V. Now, by very, very careful observation, I've established that that happened just here, about 1800 BC. Now, to get into the correct position here, to move along here very rapidly, because he only had a few seconds while it was showing, he could get into the position where it would just twinkle and no more. Now, that was a dangerous operation. If this hillside came straight down, he could have tripped when he was doing the side movement. And therefore, I reckon he used this platform. The whole point is that here is a platform which is in exactly the right position, exactly the position that megalithic man wanted for making his observations over there. And it seems, well, I'm perfectly certain he did use it. Whether it was natural or not, I don't know. I suggest that's a parapet to prevent him falling over.
Well, what are the chances that it was man-made, Ewan?
I would say about 50-50.
What would have proved it one way or another?
Well, some concrete sign of human activity, like potsherd or a post hole, a stone socket, perhaps a piece of charred timber, something like that. But we haven't had any of those.
So the excavation was inconclusive. But the significant thing is not so much that no material evidence was found on this occasion to corroborate the theory, but that for the first time a professional archaeologist has given time and attention to looking for it. Ewan Mackay.
I think the evidence that Professor Thom has given us makes it overwhelmingly probable that astronomy could have been practiced. And it seems to me that it's up to us as archaeologists to make an all-out effort to investigate as many sites as we can whether in fact Neolithic man did do this, did do the things that Professor Thom has shown could be done.
The theory of simple solar observatories isn't too hard to accept, perhaps, but at a site called Temple Wood in Argyll, Thom takes things much further. At Temple Wood there's a small stone circle, but it's not the circle that interests him. It's a group of 5 standing stones a couple of 100 yards away across the fields. The large centre stone had a special significance for Alexander Thom and for the Stone Age astronomer priests he thinks erected it.
Well, this stone's at the centre of what, in my opinion, is the most important lunar observatory in Britain. It's nothing to do with the sun, it's lunar. Standing at this stone and looking up to the notch, it shows the extreme position of the moon when it's at its farthest north. When the lower edge of the moon just comes down through that notch, it's in its extreme position, as it's set in the northwest.
Once every 19 years, the moon makes its greatest sweep of the night sky, from its rising point in the northeast to its setting point in the northwest. It's called the major standstill of the moon in the north, and here at Temple Wood, prehistoric man could capture that vital moment.
Now, why was it so important for them to get this particular moment in time?
I think it was the whole object of the thing is to predict eclipses, and by using this stone and its neighbours, one is enabled to detect a slight movement of the moon in addition to the normal 19-year cycle, and it's this additional movement of the moon which was connected with eclipses. And when this wobbles at its maximum, then you're in the middle of a danger period from eclipses, which can then happen every 173 days thereafter.
So once you've got this day, you said, right, 173 days' time, there's going to be an eclipse. And this might have been the secret of the power of the astronomer priests, the power of knowledge.
Quite possibly. If he could say that the next time the moon comes to the full, it will be eclipsed, he was obviously in a strong position.
How long would it have taken them to work out a site as precise, as exact as this one was?
Well, I think possibly something of the order of 50 to 100 years, because he could only get the observations made here along this line every 19 years, and if they missed it, they had to wait.
Now this stone clearly is given importance. It's got stones all round it.
And it's got cup and ring markings, and it's got 4 little stones round about it.
Now these cup and ring markings, they look as if a big thumb had been pressed into each one here.
Of course, there's thousands of these scattered throughout Britain, but this is the only stone in this alignment that is marked with cup and rings, and I suspect that these carry a message, if we could read it, telling us what the stone's for.
Was this a high point of their development as astronomers?
Yes, I think so. The precision with which these 3 positions are placed, showing exactly where you're to stand, the precision of that is almost unbelievable. I mean, it splits a minute of arc. I mean, that's doing better than an ordinary surveying theodolite.
Well, what about the observatories in Caithness, for instance?
Well, the observatories in Caithness do show us a little more. I don't say they were more accurate, but they contain the information which has enabled me to discover the geometric construction which was used to, as it were, compute the results once they had got them. Without this method of computing, you can't really use it.
The few people who know about this scatter of boulders near John O'Groats call it the Hill of Many Stains. But to Thom, they're a sort of megalithic graph paper, vital equipment to the Stone Age scientist. They must once have existed at all the great lunar observatories like Temple Wood if the astronomers were really to know what they were doing.
They knew what they were doing all right. This thing wasn't set out without endless headaches and trial and worry and calculation, if you like, when the calculation was done on the ground geometrically. And if you put me here in megalithic times, I could have watched this thing, knowing what I do know now.
One site in Scotland, on the island of Lewis, embodies all the elemental mysteries of the megalithic sites. Callanish, the Stonehenge of the north. It's a magical, haunting place. It's to Callanish that Professor Thom comes back again and again to refresh his sense of intimate connection with his prehistoric fellow scientists. For Callanish, so exactly aligned on a north-south axis, embodies so many features of megalithic astronomy, circle and alignment, solar observatory and lunar observatory combined. And it was Callanish that inspired him many years ago to try to crack the Stone Age code.
Well, I've sailed this coast since 1912, and 1 year we had gone out through the Sound of Harris, so you know what that's like, and you know what it's like on the outside. It's just always blowing. It's like the gale frequency up there is about 3 times what it is at Tyree. A filthy coast too, exposed and open. So when we'd done about 40 miles from the Sound of Harris up to the mouth of Loch Road, round Gallen Head, great seas pounding away on the islands there, I thought, well, we'd better go up into Loch Road. And we sailed up Loch Road, far up as we could go. And so there's a little bay there, and the light was going. I thought we'd better just anchor here. Put the pick over, and then dinner came on. We got the mainsail down, and then we looked up, and the moon was rising, and silhouetted on the moon were the Callanish stones, sticking up like fingers on the moon.
On the island skyline of Lewis, the cruciform shape of Callanish draws him like a magnet still. The big stone inside the circle is aligned exactly north and south and could have been put to many uses. A multi-purpose pointer for detecting midday, or to observe the wheeling of the stars across a meridian. And there's an alignment exactly to the west which could have shown the equinox. Jaquetta Hawkes.
I believe the thing is that he gives himself always so many choices. I see him as a man surrounded by loopholes. You see, he has so many instruments on the one hand. It can be the top of a stone, the gap between stones, it can be something in the foreground, it can be what he calls a foresight, some natural thing you pick out on the horizon. And then also so many objectives, different phases of the moon, sunrises and sunsets, summer and winter, 12 major stars. And really there is a vast amount of choice there, so that if you don't find one thing, you'd find another.
The mountain called Clisham is the setting for one of Thom's favourite observations, to demonstrate moon wobble at the major standstill. The moon brushes the top of the mountain as it goes sailing by. 87 days later it would reappear. It would pass Clisham again, but this time it wouldn't brush the top of the mountain. It would pass right behind it and touch the horizon just in the valley to the right. And so the two extremes of the wobble, which was only rediscovered by Galileo, could be observed from the stone circle of Callanish. Or that's the theory, at least.
I haven't studied the astronomical side in detail, but I don't find any great difficulty in accepting it. I don't think, though, that Professor Thom has made his case for either the megalithic yard or for the use of Pythagorean triangles as a basis for setting out the rings which are not truly circular.
Humphrey
I think
Case.
Thom has demonstrated absolutely clearly with his accurate surveys that they were laid out in this way. He has also demonstrated, what was a matter of guesswork beforehand, that they were accurately laid out to within 30 seconds of arc on celestial bodies, the movements of the sun and the moon and the first magnitude stars.
This does seem to be impossible, that people who have no kind of way of making a record to hand on to the next generation could possibly go so far. Mr. Thom believes that they actually could predict eclipses and that they could understand the lunar cycle of 19 years. And yet this was 1,000 years before they began to be able to do such things in a high civilization. I mean, after 500 BC, round about then, when the Greeks and the Mesopotamians, the Babylonians did it between them. It's a little incredible.
In my view, within a farming community at certain times of the year, there would be unlimited time to speculate on the heavenly bodies and experiment with geometrical layouts. I'm sure these people were every bit as intelligent as ourselves.
I think one needs to realize in dealing with this sort of thing, as well as in considering the geometrical setting out, that the fact that something could have been set out in a particular way is no proof that it was so set out.
A number of people, of course, have dismissed Thom's findings simply because they don't understand them. But there are one or two, particularly I have in mind Mr. A.J. Hogg, who have made serious criticisms. These are obviously got to be listened to, but I don't think, because they're directed on a very narrow front, that they really affect the soundness of the ideas that Professor Thom put forward.
The obvious next move was to see how far the theories could be carried. So Chronicle invited Alexander Thom to Brittany to find out. Karnak is the Mecca of the megalithic world. The three alignments of Lemenic, Kermario and Kerliscan dominate the whole region and bring tourists flocking in their thousands. So Alexander Thom, who beforehand knew the site only from books, recruited his team from his prolific family and also from America and Australia, and descended on Karnak in search of further mathematical facts. What might he expect to achieve there? Glyn Daniel.
Well, I think three things. First of all, we shall have, for the first time, an accurate survey of these astonishing alignments with many thousands of stones. But secondly, we shall know about the things that happen at the end of these rows. Now, most people, when they come and visit Karnak and these alignments, they just say, oh, well, they're just great stone rows. But what they miss is that they're broken up into several series. And at the end of each series of rows, there is a half ellipse or an ellipse or nearly a circle. And we shall find out whether they were built on the same kind of geometrical system as the stone circles in Britain. And the third thing is that he will be able to apply his astronomical ideas. I mean, do these alignments point to any significant place in the heavens? And there are interesting outliers. Do they point to other places, so that we shall be able to see whether in this area of northwestern France, perhaps the most important area of megalith building in the whole world, whether they have some astronomical significance too. And that will be very intriguing.
Right, hold it just now. You stay there, Robert. Hold it. All right. Right, a bit more. No, this way. This way. This way. This way. Hold it. Hold it. Back. This way. No,
Four
this
notches.
way. This way.
How many notches there?
3, 7. Nothing. Projection onto that.
For 3.5 weeks they toiled in the sun, surveying, measuring and plotting these monstrous alignments and the other extraordinary monuments of Karnak. Then Thom came home to work on his bulging notebooks. When I went to see him in his den at Dunlop after several weeks of processing and analysing the data, the preliminary results more than lived up to everything he'd hoped to find.
Well, probably the biggest job we did was the alignment that runs through here. At Lemenic.
The first accurate survey of Karnak ever made was now on paper. Only one of the lines appeared to be straight. It's now being checked for astronomical alignments and the use of the megalithic yard. And at the end, this strange enclosure of standing stones, half submerged amongst the farm buildings, is now surveyed. Only half a dozen of the stones had not been moved out of place by medieval farmers. But these original stones fitted precisely the familiar egg shapes found in Britain, and the design was based on the equally familiar Pythagorean triangle with integral sides. And this is exactly as you would have found in Britain?
Exactly. I found many of them. I found a dozen like this in Britain, based on different triangles, sometimes on the 3-4-5 triangle, sometimes on the 5-12-13. But here it's based on the 11-18-21.
Professor Thom had also been busy nearby at Chronicle, surveying an extremely unusual arrangement of stones there, apparently a square. He was inclined to ignore it at first as an aberration, but survey it he did, and found that there was more to it than met the eye. A perfect rectangle precisely aligned to the north. A diagonal divides it into two Pythagorean triangles, the classic 3-4-5 triangle measured in British megalithic yards multiplied by that mystic factor of 10, and the diagonal aligns precisely on the midsummer sunrise.
Only in this latitude, the latitude of Chronicle, would the midsummer sun rise on that bearing. In fact, if you work it out, it's within a few miles of where it should be. By the time you get up as far as Scotland, this thing becomes a square.
There's one other monument near Carnac that's always intrigued and staggered scholars and visitors alike. It stands, or stood, at the edge of the sea looking out to the Atlantic. And naturally Alexander Thom couldn't resist it either. It's simply enormous. It must once have been the biggest man-made lump of stone anywhere in the world, you feel. And as you walk in its shadow, you feel dwarfed and puny, even though it's lying on its side in bits.
In French they call it le grand menhir brisé, the great broken stone. And if you imagine it vertical as it once was, it would be just about as high as Cleopatra's Needle, about 68 feet. But it's twice as fat as Cleopatra's Needle, and its weight overall would be something like 330 tons.
Well, people have puzzled for long enough as to how it got into its position, how they ever got it up, and what brought it down, and why it broke the way it did. But I find that it actually was put there as a universal lunar foresight.
From 5 crucial points of the compass up to 15 miles away, the Grand Menhir Brisé could be used as a foresight for critical observations of the moon. A stone at the tip of the Quiberon Peninsula gave a sighting line for the major standstill of the moon as it rose above the tip of the standing Menhir Brisé every 19 years. All in all, the visit to Carnac was a vindication of all Thom's theories, to his own satisfaction at least. Poring over the figures every evening, he had seen these same patterns emerging in Brittany as he had found in Britain. They implied an intellectual common market of 4,000 years ago, in which the megalithic yardstick, the wand of power and knowledge, held sway. Alexander Thom is not the first man to try to prove that megalithic monuments might have been used once as astronomical observatories. Norman Lockyer had suggested it many years ago, and more recently Gerald Hawkins of America and Fred Hoyle have interpreted Stonehenge as an eclipse predictor.
Oh, well.
But now it's been taken much, much further. In the peaceful surroundings of Carnac, Alexander Thom and his determinedly Scottish clan of helpers have vastly extended the vision of the intellectual capacity of our prehistoric ancestors. From now on, that image of the simple nomadic primitive will no longer do. But for Alexander Thom, the Stone Age code isn't fully cracked yet.
But now that you've established that the megalith builders of Brittany were so closely connected with those of England and Scotland, what other areas do you think of their mind, of the kind of people that they were, do you think you can get at if you survey something else or attack it from some other angle?
I have an idea, but it's entirely nebulous at the moment. The cup and ring markings were a method of recording, of writing, and that they may indicate, once we can read, they may indicate what a particular stone was for. We have seen the cup and ring markings on the stone at Temple Wood, and that's on the main stone. but we can't interpret them yet.
Well, if your theories about Stone Age Einsteins have got up the back of some archaeologists, the idea that the cup and ring marks were used as writing is going to get up the backs of a lot more. Does it worry you that archaeologists...
Not in the slightest. I just go right on recording what I find.
Prehistoric man at this time isn't supposed to be like work there.
Shows us that we should not have closed minds, that we should always be prepared to accept new evidence.
But then that seems to me to leave too many loopholes.
For me, I am prepared to wait.
These people were every bit as intelligent as ourselves.
And I do not think that his proof is sufficiently strong.
It does seem to me that they do have to be taken seriously.